Hi everyone, so today we are going to continue our solid design principle playlist. So in this video we are going to study our first creational design pattern, that is singleton design pattern. So without wasting any time, let's get started and study. So singleton design pattern says that we are going to make one class and only one instance is possible. So it means that we can only make one object of that class. We cannot make multiple object of that class. So let's take an example. Suppose that I made one pizza class here. This is my pizza class, and what is going to happen, like if we are going to code in Java, you will see we can code something like that: pizza mushroom pizza equals to new pizza. This is fine because we are going to create one object, but we should not be able to do this line: pizza chicken pizza equals to new pizza. This is wrong because singleton design pattern says that we can do it only once. This action should be allowed only once. We cannot do new pizza one more time. So we have to do something like that in our code, that our class is restricted to make instance or an object only once. This is known as the single design pattern. Now you're thinking why we are going to do it, like what is the need of the single design pattern. So the simple answer is about DB connection. Think of this like that: whenever you are going to write a code in Java, then every single function is going to make a DB connection every single time. So suppose that there is a function called coming and you started making a DB connection. Another function is going to be called again making a DB connection. Instead of that, the better approach is going to be you globally define one connection. You're just going to make a connection only once, and after that you are going to use that connection and call the functions. Simple as that. You are not going to make the connection every single time. That is wrong. You are going to make multiple connection and it will increase the load on your database and it can hamper your system. Now to explain this singleton pattern, I take again that same restaurant example and let's understand it with the help of one story. So let's move to our IntelliJ. So again, let's revise the definition of our singleton pattern, that ensure that every class has only one instance and provide a global access to point of it. So this is a definition, but first of all, we are going to see a bad code and what's the problem with that. And then we'll move to the good code and how we are going to implement the singleton pattern. So suppose the story says that in a restaurant, there are multiple customers are coming and we are having two waiters. We are having multiple waiters right now. And whenever the waiter is going to come and they are going to take the bill. So basically customer comes, have the food, and now they are going to give the bill. So they call the waiter one. It means that the customer one calls the waiter one. So what is going to happen? They are going to call the billing service because customer is going to help in the billing. So they call the billing service one. I'll just write billing service one here. So after that, let's say customer pays 100 euro. Now, secondly, what happened? There is another customer who calls the waiter 2. When he calls the waiter 2, this waiter 2 is going to make another instance of billing service 2. This is the whole problem. I told you that billing service, think of this like that. There are multiple billing services, but billing service should be only one. So think of this like that. There are multiple billing service, but billing service should be one. Or you can say that there should be one counter where the whole bill should be transacted. It should be not like that there is another billing service for waiter 1, there should be another billing service for waiter 2, there should be a common billing service. So what did waiter 2 do? He created one more billing service. That is wrong. It should not happen. Now, so waiter 2 added into that billing service. And again, the customer 3 comes and calls the waiter 1. So customer 3 comes and calls the waiter 1. So it is going to add in the billing service 1. Now, at the end of the day, when manager comes and asks for the bill, so it should give you two outputs, because billing service 1 and billing service 2 are the two different entities. It is giving you 200 and 150, but the correct answer is going to be 350 because there should be only one answer. There should be no two instances running. We only want one billing service and the answer should be 350 because there can be no two billing services. Now let's move to the good pattern, how we are going to restrict it. So again, let's go to the restaurant code first of all. The story is going to be same. Multiple customers are coming, but now we are going to have only one billing service. Again, billing service waiter 1 is going to create an add in total 100. Billing service 2 again create an instance. It means that again waiter 2 is going to create an instance. He tried to make an instance 2 this time also. We are not stopping him. Okay. He again tried to make an instance. So third time again the customer comes, he calls the waiter 1 and n in total. But this time when you will see the result, when the manager will ask the total by the end of the day, they both are going to give you 350 and 350. How this happen in the good code? Let's understand it. It's pretty simple. What we did it, if I go to the billing service this time, if we go to the billing service this time, here you will see what I did it. First of all, the first step is going to be how to make a singleton class. The first step is going to be to make a private constructor. So in the bad code where you will see that we were going to make a class equals to new billing, here you will see in a good code where you're going to use billing service dot get instance, because we cannot call the constructor because we are going to make a private constructor. That this is our private constructor, so that we cannot make our so it means that we are not going to make an object with the help of the constructor. We restrict it. That is the first point of our billing. That is the first point of our singleton class. Second point is that we are going to make one instance variable. We define it as null right now. So it means that our object is null right now. And third step that we are going to do, we are going to make one static method get instance. In that instance, what we are going to do, if instance equals to null, then we are going to create an instance. Other than that, if we have already put a value into an instance variable, it means that we have already defined the instance. We have created an object once. Next time what we are going to do, we are going to return that instance. So if I go to this code, billing service.get instance, the first time it created an instance, it is going to create an instance. But second time what is going to happen, it is going to return the same instance. It is not going to create a new one. This is how our singleton pattern is going to return the same object every single time. It is not going to create an object another time. So it is not going to create an object second time. We restricted it with the help of this private constructor with this particular variable and with this static function that we have created get instance. We restricted that. Now, there are multiple scenarios that we are going to study that are usually asked in the interviews. So this is a simple concept of the singleton design pattern, but what are the questions that are usually asked related to single design pattern? Let's understand them as well. So now let's see, if you have a multi-threaded application, then what is going to happen? First of all, again, we have a private constructor. We have again that static variable. But the only thing that we have changed is that we are going to use this synchronize keyword. But as you are seeing it, we are using this synchronize keyword under the instance and we are again checking it. Why we are doing it inside the instance equals to null thing? Why we are doing it inside this if statement? Because multiple threaded are going to come and they can cross this condition, because think of this like two threaded cross this instance equals to null condition. Now again, here when we are using the synchronize keyword, it means that only one thread can go inside. After that also, for having the safety, we are going to check it one more time. It means that the multiple threads can pass this previous check. So for the safety, we are going to again check if the instance equals to null. Then only we are going to create a new billing singleton. Other than that, we are just going to return the new instance. And this is how you can ensure that only one thread goes inside this function. And this is how you can make this function thread safe. This is the answer of your multi-threaded question. Secondly, there is one more question that is related to singleton, is that how we can do the lazy initialization and a eager initialization. The answer that we are seeing it, the code that we are seeing it right now is a code of the lazy initialization, because here what is going to happen, instance equals to null. When the restro function is going to call dot get instance function, at that time we are going to create an object. It means we are lazily implementing that class. We are going to create the object whenever there is a requirement. So that is known as a lazy initialization. It means that whenever we need an object, we are creating it. But what is eager initialization? Eager initialization means that we are going to create an object at the starting of the code. So we are going to create an object whenever the code runs. But the problem is, think of this like that. We make a DB connection in our code, but no one called that API and never that function is called. So it means that we have make a DB connection, we write the code in which we are going to connect with a Mongo database or anything, but no one is going to call that function. No one is going to call that code right now. It means that we are going to waste the resources in the eager initialization. So this is the code of the eager initialization. It means that again, we have that private constructor, but in the instance, instead of passing null, we are just going to do new billing service singleton. And after that, get instance is going to be return instance. This is the code of our eager initialization. After that, let's move to the final code Okay, that is something that is usually asked in the interview, and it is the most important interview question. I made this billing service final singleton, and here you will find the final code that is specially for the interview. Here I want you to revise one more time. We should have this private constructor, static instance variable, and after that static function for creating an instance, eager initialization and lazy initialization we have just covered. Now, let's move to the sixth and seventh point. These are the most important one for our interview, that is serializable and clonable. So serializable says that whenever you are going to convert an object into a file and then into bytes and again going to convert it back. So what happened? At the time when this conversion is going to happen, it creates a new object in between. Second one is clonable, means that by using the .clone function, you can create a new object. Okay, this is how this is going to happen with the help of the reflection in Java. In Java, what you can do it, you can just convert your private constructor into public constructor by using the reflection framework in Java. Now, we have to stop that. We have to stop these two things as well. So, to solve this problem, we are going to implement serializable and the clonable interface. When I'll go down here, I just override this read resolve function and I'm going to return instance. And in the clonable also, I override this function and I'm going to return the same instance. Like everyone, like think of this like that. If someone tries to clone my class, if someone tries to make a clone of my object, here also this clonable function is going to call and it is already overridden and it is going to return the same instance. If someone tries to read resolve, it means that someone is going to try and make a new object with the help of the bytes and everything by doing the serialization steps. Here also we are going to return the same instance. So we are making sure that our object should not be created second time. We are ensuring that it is known as a singleton design pattern, and this is the final code that is usually asked in the interview. You can tell them in the interviews, and maybe you will get score. So thank you for watching me, and in the next video we are going to study about the factory design pattern, and bye bye.